So today we start section 8.5, using intercept form to graph and to write equations. Now this is a really long section. First part will be graphing quadratic functions in intercept form, using the intercept form to find zeros, using characteristics of a graph to write quadratic functions. And I decided to skip this part about cubic functions because we can do it next year in algebra too. So when you're graphing a function in intercept form is just the factored form. So for example, x squared plus 7x minus 8. What happens when you solve this? Well, that means you set it equal to 0, factor it. What are the two factors of -8 that add to give you positive 7? So that would be x plus 8, x minus 1. And then you set each of these equal to 0, and you find out that the values that make the equation true are -8 and 1. So what about the graph? When you see the graph goes through the x values of -8 and 1. So we did this a while ago when we were solving these equations. Now we're going to put it all together because these solutions are the x-intercepts of the graph. So intercept form is actually the factored form of our quadratic equation. Okay, it gives the zeros or the solutions or the x-intercepts. Okay? So again, core concept here. The x-intercepts are p and q, and notice it's minus p minus q here. So p and q. The axis of symmetry is halfway between the x-intercepts. In other words, the average. So to find the axis of symmetry, you add the two x coordinates together, divide by 2. So you're finding the average distance between the two. The graph opens up as usual when a is positive. The graph opens down when a is negative. Now what it's not telling you here is how you find the vertex itself. I'm going to add that in. Once you know the axis of symmetry, you plug that value back into your equation, and that will give you the y coordinate of your vertex. So if we're looking back at the previous equation, this vertex right here, well, first of all, I would find the axis of symmetry by doing -8 plus 1 divided by 2, and I get -7/2, which is -3.5. So this would be -3.5, comma, and then to find the next, if I wanted to find the y value, I would plug it back in. So coming over to my calculator, -3.5 squared plus 7, plus 7 times -3.5 minus 8. So that gives me the y coordinate of the vertex as -20.25. And then you can see here is our y-intercept. And we find the y-intercept by plugging in 0 for x. So the y-intercept is found by doing 0 squared plus 7 times 0 minus 8. Or you can remember that the c in our equation is always the y-intercept. So moving on to graphing. Now, I realize that when you do your online homework that you're just asked to match the graph. So that's why you're actually going to have a worksheet this time around where you have to do one of these by hand. So when it is an intercept form or factored form, we're going to identify that a is -1, that p will be, now that notice this is x minus, my formula is always minus, so x minus -1. So it's the opposite. So p is -1 and q will be +5. Okay, because another way to say x plus 1 is to think of it as x minus -1. So this is p. So that means my intercepts are -1 and 5. Another way to think of it is you could set it equal to 0 and solve. So I'm going to plot those, -1, +5. Because A is negative, I know my graph opens down. Now I need to find the axis of symmetry, and I do that by adding the two x values together and dividing by 2. That gives me the average. So -1 + 5 divided by 2, that's 4/2, which is 2. So my axis of symmetry is at x = 2. Now I want to find and plot the vertex as well as the x, as well as the, I'm sorry, I want to plot the y coordinate. So I'm going to plug in 2 for x into my original equation. So -1 times 3 is -3, -3 times -3 is +9. So my vertex is up here and my parabola opens down. Now there is one other value that I could find. I could also find the y-intercept. This is the y-intercept is what you get when you plug in 0 for x. So I could find the y-intercept pretty easily. So I would get -1 times 1 times -5. So my y-intercept would be 0, 5. Okay, so my graph isn't very good. So 0, 5 is right there. So my graph should actually curve out a little bit more. But you get the general idea. All right, and then I draw my parabola through my points, which I did. Domain, still all real numbers. And the range is based on the x value or the y value of the vertex, which is 9. My graph is below, so it's less than or equal to. This is what I forgot in the previous videos, the or equal to part. Okay, one more example, and then I'll move on to the next video. So to graph this one, first thing I need to do is identify my x-intercepts, which are 1 and -3. So I plot those, 1, -3. Now I'm going to find the axis of symmetry. My axis of symmetry is found by adding the two x coordinates together and dividing by 2. So -2/2 equals -1. So there's my axis of symmetry. It's halfway between. Now I need to find the y coordinate of my axis of symmetry. So I plug in -1 for x. -1 minus 1 is -2. -1 plus 3 is +2. So the y coordinate of my vertex is -4. So my vertex is at -1, -4. Now, A is an understood 1, and it's positive, so my graph will open up. Now, the only other thing I could do is I could find the y-intercept by plugging in 0 for x. And I find that my y-intercept is at 0, -3. Now I connect my points. My domain, again, pretty easy. It's always all real numbers. My range is based on the y value of the vertex, and it's above, so it's greater than or equal to -4. So I'm going to stop there, and then I'll come back and I'll do the other examples of graphs that are not in intercept form.